Hey guys, I'm Jay. Today is my LeetCode review vlog on the 15th problem, threesome. We are given an integer array nums. We have to return all the triplets, nums of I, nums of j, and nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and their value added up to the 0. We have to all notice that the solution state must not contain duplicate triplets. And then let's get started quickly with the intuition first. So my first straightforward intuition is I can create a 3-layer for loop to traverse all the possible combinations with brute force method. Brute force. And the first code to start it is we're going to create a hash set to store all the possible triplets. And hash set can help us to avoid all the duplicates for this problem. Let's create a state of list of integer. And result equals new hash set. And then we're going to create an n variable, and with the value of the length of the input nums array, nums.length. And then the very important step is we have to use arrays.sort method to sort our nums array. This is because sorting is to make it easier to avoid duplicates with the feature of a hash set. And then we create 3-layer for loop here. Int I starting at 0, I is less than n, and increment I. And the second for loop in j started with I plus 1. This is because our second element must be unique from the first element. J is less than n, and increment j. And the third for loop int k start with j plus 1, and k is less than n, and increment k. And inside the third for loop, we are going to check for their sum. If nums of I plus nums of j plus nums of k equals 0. If so, we're going to add this triplet into our hash set. And the code is result add arrays dot as list nums of I, nums of j, and nums of k. And out of the 3 for loop, we just return a new array list, but we have to convert our hash set into the array list as the problem asks for. We just set the result as the input array, and then let's check for correctness. And the time complexity for the brute force solution, it is big O of n cubed. This is because we got 3 nested for loop. And our space complexity is big of n for the hash set we use to store the result. As the compiler told us, we got time limited exceeded exception here. This is because our time complexity is big O of n cubed, which is now the best solution. And there is another better solution with better time complexity, which is called two-pointer technique. So we just get started with the second approach quickly. So our second approach, which is called two-pointer, and our detailed solution is we can use the arrays.sort to sort the input array, and then we're going to create 2 pointers to find a triplet efficiently. And then let's get started with the code right now. The first is array.sort to sort the input nums array. This is because sort array can help us to manage duplicates and leverage the feature of two-pointer technique. And then we're going to create list of integer, and started with a new array list instance. And then we're going to create a for loop to traverse the nums array to find the possible first elements. And the code is int I started at 0 and I is less than num.length. There is one thing we have to notice. All the possible triplets must contain at least one non-positive value. So our mission here is to find the first element, who is the non-positive value, and then we are going to find the second and the third value in the further state. So our code here is we have to make sure nums of I, which is our first element, must be less than or equal to 0. And then we are going to increment I to check for the next first element. And inside the for loop, then we're going to do is we have to check and skip the duplicates for our first element. And the code is very simple. We just check nums of I minus 1 is not equal to nums of I. If so, which means we found another new unique possible first element. But there's one thing we have to notice. Our I iterate pointer started at 0. So if nums of 0 minus 1, which could be negative, so it would meet an array index out of bounds exception. So we have to avoid this situation happen. Therefore, we are going to add a precondition before it, which is if I is equal to 0 or nums of I minus 1 is not equal to nums of I, then we won't meet any exception right now. And the code inside if is we're going to create another method to help us to find the second and the third elements. Let's say is toSum with two-pointer method. And our input parameters could be nums, I, and result we created before. And out of the for loop, we just return the result as the problem asks for. And then we're going to implement the toSum with two-pointer method. Let's say void toSum with two-pointer. And the type of the input parameter could be integer array, called nums, and integer I, and list of integer. Integer called result. And inside this method, the first step is we're going to create two pointers. The first called left pointer and started at I plus 1. This is because our second element must be unique from the first element. And we create another right pointer started at num.length minus 1. And then we're going to create a while loop to check for all the possible second and third elements. And the condition is left must be less than right pointer. And inside it, we are going to check for their sum. Sum is equal to nums of I plus nums of left plus nums of right. If their sum is less than 0, which means we have to find a better or bigger sum in the next iteration. So we're going to increment left pointer. This is because we have already sorted our nums array before. And the second condition is, what if sum is bigger than 0, which means we have to find a smaller sum in the next iteration. So we are going to decrement right pointer. And in the final condition, which is sum is exactly equal to 0, and that's the triplet we want found. So we just add this triplet into our result. Result dot add arrays of list with nums of I, nums of left, and nums of right. And then we have to increment left pointer and decrement right pointer to prepare for the next iteration. There's one thing very important here is we have to avoid the duplicates for a second and a third element. So the code is, we're going to check the value at the left pointer and the left minus 1 pointer. So the code is nums of left, if nums of left is equal to nums of left minus 1, which means we found the duplicates and we have to skip it. We have to increment left pointer. But there's one thing we have to notice is we have to make sure left is always less than right pointer, and we cannot ignore it. So we have to double check it in this situation. And this is all of code for our second approach. And then let's check for correctness. And our time complexity for our second approach, it is big O of n squared. This is because sorting takes only big O of n times log n. But our first iteration takes n time. And our second two pointers take another n times. So n times n is big O of n squared. And our space complexity could be big O of n, and the n stands for the result list. And also could be big O of log n. This is because we use arrays.sort to sort the nums array. And the algorithm inside the arrays.sort is the quicksort algorithm. And this is the end of my LeetCode review vlog on the 3-sum problem. And you can also check for the detailed notes of these two approaches and their intuition, their code, and their complexity analysis on my GitHub repository here. And thank you guys for your watching. See you next time.